All right, we're ready to move to our next phase, and that is cutting slots, T-slots, and dovetails. You'll often be asked to perform these tasks in a machine shop. There's some simple tips and tricks that I'll share with you. Our first slot is going to be with a 1/2-inch cutter, 3 flute, high-speed steel, and a bar of 7075 T6 aluminum. For those of you that were pretty good at math, simply calculate the RPM speed in your head, and let's get started. Remember to choke our cutter up close. Turn on our machine. We're going to cut a slot that is a 1/2 inch deep. So we're simply going to come in contact with the workpiece by slowly raising the table until our cutter just contacts. Okay, at that point we're going to re-zero the knee, loosen the lock ring, turn our dial. We're going to take 100 thousandths at a pass. Well, let's be a big shot. Let's go 200 thousandths. Lock our y-axis down. We want a nice straight slot. We made it through to the other side. Now let's take an additional 200 thousandths. So our slot depth now is 400. Okay, now let's sneak up on our final depth. Take about 90 thousandths. Again in a roughing cut. Now if we wanted to be really precise, we would turn off the machine, take our depth mic or some sort of measuring instrument and measure the exact depth of that slot. For all practical purposes, we're going to assume that it's 490 thousandths. We're going to go ahead and take the last 10 thousandths as a finished pass. We're going to slow the feed rate down a little bit. Now, since we started pushing the cutter really fast through there, we've got kind of a ragged edge on the sides of our slot. So we can go in and clean those up, and we're going to offset the mill cutter relative to the slot 2 to 3 thousandths on each side. Adjust your cutter 3 thousandths to one side. We're going to do these in a climb cut. Okay, go over the other side. Now we've cleaned our slots up. If we're going to be machining a slot that has to be precise in width and depth, let's say we want to machine a slot that's exactly a 1/2 inch wide by a 1/2 inch deep, we couldn't do it with a 1/2 inch cutter. We'd want to use a 3/8 cutter or a 1/2 inch cutter that has been resharpened smaller than a 1/2 inch to, let's say, 480, 475, and then offset on either side, keeping the slot centered now in the piece of material in order to get the correct width as well as depth of that given slot. Now let's move on to cutting a T-slot. We'll show you a T-slot cutter. This is a Woodruff cutter, and this is what we would cut a T-slot with. If we were making a special piece of tooling, we need to keep our slot width larger than what the shank of the cutter is, depending upon the depth that we are machining. This measurement is 310 thousandths, so anything over 5/16 will allow this to track through the slot as we cut. Now let's take a look at an exact part that this type of cutter will produce. Okay, this is the type of operation that we would cut. This T-slot cutter is just going to come in and reproduce that part. We can have a locking gib in there, a washer or spacer bar that will pull something up tight against this surface. Alright, so we'll need to cut our slot initially, and we're going to cut that to a depth of 400 thousandths using a 3/8 end mill. Okay, bring our cutter in contact with the workpiece. Okay, lock our table down. Let's take 200 thousandths in a pass. And another 200 thousandths for a total depth of 400 thousandths. We'll clean up the sides of the slot. Index over 10 thousandths on each side. Okay, now take our mill back to center. We're now ready to install our Woodruff cutter. Now, due to its larger diameter, the number of teeth and the type of teeth that it has, we're going to have to turn that Woodruff cutter a lot slower than we would the ordinary end mill. I'm going to slow that down to about 660 RPM. Make sure and use plenty of fluid. Okay, now we're going to bring the cutter in close to the work, and we want to start that T-slot right at the base of our slot. So two ways that we can do it. We can simply clear the chips out of the slot, bring the cutter in, line up a tooth and a flute inside the slot, bring the quill down until we have contact, lock the quill down, or we can start at the top like we did with our cutter initially, contact the top, raise the knee 400 thousandths. Whatever works for you will work for me. Both methods are acceptable. All right, now watch slowly as we enter the cutter into the workpiece. Make sure and use lots of fluid. Voila, you've cut your first T-slot. Pretty simple, yet a very vital thing to know when we're building a piece of tooling. We may even want to manufacture a little mill bed, and we're going to need some T-slots in it to clamp a part down, or a tooling fixture, and we'll also build some companion T-nuts to go in those slots in order to hold a fixture or a part down. Okay, so that's how we produce a T-slot. Let's go to the next type of slot, or what can be referred to as a slot of a different shape called a dovetail. We have a special dovetail cutter. Now keep in mind, when we prepare a dovetail, again, we need to have clearance here at the top of the shank in order for the dovetail to pass through the material. So we can take our dial calipers, measure that, or if we're trying to duplicate a dovetail that's, say, a little bit wider, we would simply cut a wider slot as our sample or as the print requires. Now, look at how many flutes that we have on the dovetail cutter, very similar to the Woodruff cutter. So again, we're going to be turning this at a slower RPM than what we would if we were using a standard end mill. All right, so let's make our slot for the dovetail and get started. Make sure and choke your cutters up. We don't want a lot of exposed cutter hanging down below the collet. We want to have rigid work setups, and we want to have rigid cutter setups. Okay, we'll bring our tool down in contact. We're going to cut another 3/8 slot. Better speed up the RPM on that, hadn't we? Left it in the Woodruff cutting mode. There, that sounds a little better. All right, let's cut this slot 250 thousandths deep, and let's take it all in one pass. Install our dovetail cutter. Kick our speed down. Okay, and again, the same rule applies as with the Woodruff cutter. We can come in and make contact on the top of the part, dial down 250 thousandths, or we can just take a tooth, line it up with the slot, contact our work, back the cutter out, turn it on. We're now ready to go. Again, a lot of lubricant on that cutter. Listen to the cutter as it enters the material. Okay, you can see we've got 3 different types of slots now. Standard conventional slot using a standard end mill, a T-slot using a standard end mill and a Woodruff cutter, and a dovetail slot. If you're working in the gun trade, you'll be asked to cut a lot of dovetails to push in front sights. If you're working on a gib, this is the type of style you can use. Cut a dovetail in order to be able to adjust something for tension. Now, if we simply want to widen the dovetail, we just index the cutter left or right. I prefer to climb cut and just take a few thousandths at a pass so we have a beautiful finish on the inside of our dovetail. You can file a little bit on the edge of the dovetail so we create a starting point if we have a filler block or another piece of material that we're trying to mate. Dovetails come in all shapes and sizes. You've got 45 degree, 60 degree, 82 degree dovetails, so be specific when you call out for a part that has a dovetail in the machining process. Now, let's go over and we will do a stepped slot using a smaller cutter and show you how to expand that cutter for a wider width slot. Okay, bring our cutter in contact with the work. We'll cut a depth of 400 thousandths. Raise the slot up 200. Okay, let's take 400 thousandths all in one pass, see how the cutter responds. Okay, no problem. Outside of a cloud of billowing secondhand smoke, we achieved that cut in one pass. Now, let's go ahead and lower the mill bed 200 thousandths. And off of that same setting, we've now got a 3/8 slot. We're going to want to make it a 1/2 inch wide at the top. So a half minus 3/8 is 1/8, or 62.5 thousandths per side. So you're simply going to lock down your gibs, take the backlash out of our dial by turning it in the direction that we want, adjust our lock ring and adjust our bezel to read at 0, and we're going to index over 62.5 thousandths. 10, 20, 30, 40, 50, 62.5 thousandths. Lock the bed down. Okay. Keep the bed locked. Take the backlash out going the other direction. Set it at 0. 62.5 plus 62.5 is 1/8. So I simply go the other direction, 125 thousandths. We're now going to cut the other edge of that slot. All right, there we have it. Very, very easy to do. We've made a larger slot with a smaller cutter. We've made the two kind of an inverted U there, and for any width that we want. So we've got 4 different types of slots, and let's review them from the beginning. We've got just a standard slot done with a 1/2 inch mill cutter. We have the T slot, which is very popular in the use of tooling. We've got a dovetail, and then we've got another standard slot that we've just opened up at the top to accept another part. Very simple and easy to do. Remember, we want to have the appropriate cutting speeds. We want to take careful measurements for the width and depth of the slot. If we are calling for a specific width of a slot, we have to use a cutter that is smaller than the desired width of the slot, so we can come and clean up the sides once we've bulked out the material. Remember, when we're cutting a dovetail, it's always advisable to remove a bulk of the material by slotting the top of the dovetail first, and then come in with your dovetail cutter and bring it to size. All right, that pretty well concludes slots, T-slots, and dovetails. Let's move forward.